myself Ketan Bhavsar, Assistant Professor in LG Engineering College, Ahmedabad. In today's session, we discuss about parallel communication port, or we discuss about the different types of protocol in parallel communication. Now, in previous session, we already discussed about different types of protocol like serial communication is there, parallel communication is there, wireless communication is there. But now we are focusing on a parallel communication. Now, what is parallel communication? Which type of the protocols comes inside a parallel communication? So let's see in the depth from chapter number 2. Now, parallel communication. What is parallel communication? The communication between the short distance, generally between circuit to circuit only. So parallel communication is used when you have a very limited amount of distance. Means it is not used for the long way communication. Why it is not used for the long way communication or long range communication? Because of some certain limitations. So let's see what exactly the advantage of parallel communication. So number of 8 bits over the wire in parallel, high data transfer rate. What exactly the disadvantage? So more number of wires and high capacitance result in delay, and also the package loss ratio because of the delay. So here we have highlighted only few advantages and few disadvantages. Now, we in daily routine life or in some basic projects, we use this type of interfacing modules in our projects, like we're talking about LCD and keyboard. What is LCD and keyboard? So these are the parallel communication protocol. Like LCD, we use a 16 cross 2 LCD, we use a 20 cross 4 LCD, we use 16 cross 4, 16 cross 2, 20 cross 4, 32 cross 2, 32 cross 4. So there are the number of LCDs is there. And for that, it is used in two ways. Some of the module is used inside, we can say that control mode, and some of the mode we can say that it is a data mode. So in terms of the data mode, it is generally use a handshaking based approach. In terms of the handshaking based approach, it transmit the data through the data pins, and according to the control pin operation, it will control the data rate. So basically, the LCD is one of the best example for the parallel communication. Right now, we use a 8-bit data mode or 4-bit data mode for the communication. Similarly, for the keyboard, in terms of the keyboard, we use a PS2, we use a 4x4 keyboard matrix is there. So there are a number of matrix modules. In that, we use 8 data pins for the row and for the column operation. So these are the best example for the parallel communication. If you're talking about any LCD, it comes with basically parallel communication. But right now, in the few LCD, it's based on the I2C module also. So there are only 2 data lines, pins SDL and SCL. So it's that already be seen in previous session. Now the most popular, and we can say that the most famous bus architecture is ISA, IBM Standard Architecture bus for the communication point of view in terms of parallel communication. Connect only embedded devices means you can connect with any embedded devices. Means if you are talking about a microcontroller, microprocessor, any type of the microprocessor, any type of microcontroller. There is no geographical addresses that you can directly communicate with it. ISA bus memory access can have a range of 640 KB to inbuilt 15 to 16 megabytes. So basically, it's starting with 1 MB to the 16 MB. So there is no memory map means there is no required to to handshake some IO configuration and to handshake some data configurability. So there is no need to any type of the data configurations. Parallel communication to the PCI bus means peripheral component interfaces module. So it is totally independent from the IBM. The PCI is generally work on the 32 bits per second rate in terms of 32 megabytes, and also 64 bits in 66 megahertz. So PCI extend from 16 bits to 100 megahertz configurable speed. So you can transmit a high speed data using the PCI, but the limitation is only that you have a very limited amount of distance. And if it is a large communication, or you have to transfer the data over the large, and then you can go with the Ethernet, and right now it's not very popular in this. PCI bus feature, which type of the feature the PCI bus have? It is a 32-bit data and address bus extend to 64 bits, synchronous and asynchronous throughout the 132 to 528 megabytes per second. Automatically detect and interfacing modules. There is no need to use manual operations. It automatically detect when it comes with a peripheral interfaces. A device identification address, there are the 3 ways in terms of the device identification systems: IO port based, memory location based, and configure register to total 256 bits, because ultimately we have a range of 8-bit configuration. So 2 to the power of 8 means we are talking about the 256-bit configuration. Really, in this session, we discuss about the different types of protocol. In previous session, we also discussed about the serial protocol, which is related to the I2C, USB, UART. In UART, basically, I want to tell you that in UART we have different types of a protocol which is related to UART, like UARTs means synchronous or asynchronous means UART. Means it can be communicated with a serial communication, or it can be communicated with the parallel communication in terms of an asynchronous way. Means it transmit your data from asynchronous to synchronous to provide the conductivity. And also UART is play a main role when you have to communicate with the other type of devices which is related to the asynchronous mode. So UART is one of the most popular communication way that we are using in the past communication. Like if you're talking about the 8051 mode, if you're talking about the PIC microcontroller, and we are using the RS-232 board configuration. What is RS-232? It is generally used as a DB9 connector, which generally used to communicate or to transmit the data from a sensor to the microcontroller. And we are using the MAX232 IC, means it's a TTL based IC, which convert your data into the transistor level. Why? Because our microcontroller can understand only the transistor configuration, right? It can understand only the transistor level configuration. It will not understand other type of languages. So basically, UART is one of the most popular type of protocol that we are using in the past. Right now, I2C is one of the most popular protocol in current scenario, in current technology, because I2C is each and everywhere, because it can communicate only two wire, SDA and SCA, that I already explained you. SDA means it is deal with a addressing mode, and when you're talking about the SCL, then SCL basically in terms of the clock based configuration, in terms of the synchronization thing, in terms of the clock. So basically, when you're talking about the I2C, then it can be communicated on a clock based concept in terms of the synchronization point of view. When you're talking about a USB, then USB have only 4 wire: VCC, ground, 3X and RX. Basically the transmitter data and receiver data. So I2C is also very popular when you have to communicate with the sensor configurability, when you have to communicate with any type of the sensor. Because right now number of sensors are generally capable, or I can say that it support only the I2C protocol, because it saves the minimum number of your pins of your microcontroller, and if it saves the number of pins, that you can use that particular pin in some other applications, or you can expand your application. This there is no need to switch a microcontroller. So this one is the best example. If you connect a normal LCD with your microcontroller, then ultimately it takes 4 data pins and 2 address pins. So ultimately it occupies 6 pins. And if you are connected with the I2C LCD, then it requires only 2 pins. So you can save your 4 pins. So I2C is one of the best example when you have to communicate with a data rate, when you have to communicate with the number of periprocesses in terms of sensors. USB, that I already tell you, the USB is one of the most popular type of communication protocol in current technology, because it transmits the data very fast. Then PCI and ISA. See, PCI and ISA right now we are not using in practical application, because I already told you the certain limitations of the PCI microcontroller is there. PCI is support only the few configurability. It can be communicated in terms of the short range only, short distance only. It cannot communicate on the large distance. So these are some certain limitations of PCI. Similarly, in terms of the ISA bus architecture, in terms of the IBM, the one of the best example of ISA protocol that we are did in old cameras. In the old camera, you have to, if you have to transmit the data from laptop to your camera, then we have to use ISA bus standard or ISA bus architecture. So that is one of the most popular type of a technique on that days. So make sure that this we have already studied this type of the protocol. We already studied the USB, I2C, UART, which is one of the most popular. UART is one of the most popular for transmitting the data in previous technology. Right now we are using the Arduino board, right? We are using the basically Raspberry Pi board. In Arduino board, you can see the TX and RX pin is already there. What is TX and RX? TX and RX is nothing but it just use a communication. It provides the communication between data transfer from source to destination, right? So basically, we study this type of the protocols, and this all the protocol in the depth. So I hope that you are getting the idea of what exactly I am trying to convey about these different types of protocol, what exactly these different types of protocol is, and how it will support to your microcontroller. So I hope that you are getting the idea of what exactly the parallel communication is, what exactly the PCI is there, ISA bus is there, And also in the next session we will discuss about the AMBA protocol, which is one of the most popular protocol in current generation and current technology which is going on. And also we focus about the different types of module configurability. So basically when you're talking about a PCI bus, when you're talking about basically ISA bus architecture, so we have to make sure that everyone have a configured register bits, everyone have a memory location configuration, everyone have a IO port. Everyone have a 16-bit to 528 megabits per second rate. Automatically it will detect, means it is a transparent, or we can say the fast communication possible. And also here PCI have a range of 32-bit to 33 megahertz, 64 to 66 megahertz, and similarly it goes in 100 megahertz. So basically, when we have to communicate very fastly but a limited amount of area, then we have definitely you have to go with PCI. Definitely you can go with the ISA configurations, but make sure that it have a possibility of data loss because of the capacitors added inside the wires, and 8-bit data will be transferred. So these are the certain limitations in PCI bus, and because of that reason we use right now only wireless and serial communication. We use a USB right now, very popular, right? Why we use a USB? It's a serial communication, but it losses a very less amount of data. So this is a main difference between serial, parallel and wireless communication. So make sure that when you communicate with current technology, then you definitely go with only two protocols, wireless or serial. We are not using parallel. In the previous years, before 2 years, 3 years or 5 years, we are using the printer port. It's a 32-bit port, or we can say the 32 pins port. It is a very slow in terms of data rate losses, but definitely it's a fast for the transfer rate. So I hope that you are getting the idea of what exactly I'm trying to convey about the PCI and ISA bus. I just give you the overview about what exactly PCI is, what exactly ISA is, right? So if there are any doubt which is related to this particular communication bus in terms of the parallel communication, so you can feel free to contact me. So thank you for watching.